morning, everyone, and welcome to the Astro Network, giving you the most accurate and reliable source of planetary weather forecasts. I'm your host, Caroline, and this is my partner and field reporter, Al. Say hi, Al.
Good morning, Caroline. Hope everything's great back on Earth at the studio while I'm out here with the elements in the field.
Here on the Astro Network, we work tirelessly to give our viewers the best news about our solar system planets' climates. Want to get away to Saturn? We'll let you know if the atmosphere will burn your skin off that day. Want to take a day trip to Uranus? Let's hope the axis isn't that tilted that day.
Being out on the field helps us give you live updates around the clock of planets' atmospheres so you can see any climate anywhere.
We're beginning our forecast as we always do with the rocky planet closest to our sun, Mercury. The composition of Mercury consists of an iron-nickel core and a rocky outer layer. Al, how's it looking down there?
Well, Caroline, I'm currently on the day side of Mercury where it's about 800 degrees Fahrenheit. It's hot enough to melt lead here. Being about 50 million kilometers from the sun is brutal, but perfect if you're looking for a sunny day.
Hopefully you aren't getting hit by too many sun particles from the solar winds today.
Those darn solar particles. Yup, the precipitation actually doesn't look too bad. Because Mercury's magnetosphere does not protect it from the sun's radiation, make sure you bring some heavy SPF.
Yeah, Al. I can only imagine how hot it must be there, as Mercury's atmosphere is very thin and tenuous. Because of this, Mercury actually doesn't trap any heat in its atmosphere. How are you so hot then, Al?
Well, because Mercury does not have any tilt, there is a dramatic temperature difference depending on if you're on the day side or the night side. If you're on the day side, like I currently am, you're on the side closest to the sun at that time. If I were on the night side, things would be a lot different.
Al, did you just teleport to the night side? Also, how are you even breathing on Mercury? There's no oxygen present, only sodium, magnesium, and calcium.
Don't ask silly questions, Caroline. Because Mercury has one of the most eccentric orbits of the planets in our solar system, temperature varies throughout the orbit. That's the reason why a Mercury year is so short. Equivalently, it's about 88 Earth days. Anyway, now that I'm on the night side, temperature has dropped to around negative 280 degrees Fahrenheit.
Well, even though Mercury receives the most direct amount of sunlight from the sun, we aren't even at our hottest planet in our solar system yet. That leads us to our next planet in the forecast, Venus. Venus's composition remains an iron-nickel core and a thick, rocky outer layer.
Wow, that was a great hour of tanning. Hot doesn't even describe how intense the heat is here. Venus's extreme heat is due to its atmosphere, which consists mostly of carbon dioxide and small amounts of nitrogen. There are even some sulfur clouds out today. The greenhouse effect here is so strong that Venus is hotter than Mercury, despite being further away from the sun.
Wow, it must be rough out there. In fact, Venus's atmosphere is so thick that it results in pressures 90 times stronger than Earth's. It acquired much of the gas from its atmosphere gravitationally during formation. Al, how are you holding up?
The clouds are still pretty thick here on Venus. Because the thick clouds create a shield from the sun, Venus actually doesn't experience any seasons or temperature fluctuations. In addition to the cloudy sky, high power winds at about 200 miles per hour keep the clouds in constant motion.
Wow, if you're looking for a summer getaway, Venus is not the place to go.
So Caroline, since you're already on Earth, why don't you give the forecast there?
Sure thing, Al. Not like I do any of the hard work around here anyway. Down here in the troposphere, it's a cozy 78 degrees Fahrenheit. That's only because we're near the equator in sunny Florida. Near the poles, it's a freezing negative 30 degrees.
Troposphere? What's that? Is that a city?
No, Al. It's a layer of the Earth's atmosphere. There are 4 layers, in fact, beginning with the troposphere, stratosphere, mesosphere, and thermosphere.
Wait, Mesopotamia? I've heard of that.
No, the mesosphere, not Mesopotamia. Let me explain. The troposphere is the lowest layer. That's where clouds are formed and weather occurs. Then there's the stratosphere, which is rich in ozone. This layer heats up our atmosphere due to the presence of greenhouse gases. Then there's the mesosphere. It can get pretty cold up there. We still don't know that much about it, but we do know that meteors typically burn up there. Finally, there's the thermosphere. At this point, the air is so thin that you're practically in space. The International Space Station orbits there.
Wow, we have quite a diverse atmosphere. Aside from nitrogen, which comprises 78% of the atmosphere, there are also many other compounds like oxygen, neon, CO2, and more.
That's not the only thing that's diverse. The diversity of climate due to Earth's tilt in orbit is the reason for the diversity of life on our planet.
Is that why we have over 300 breeds of dogs on Earth?
Not quite, you silly neutrino.
Can you tell me more about that climate change phenomenon that all the conspiracy theorists talk about?
Sure thing. Recently, the Earth has witnessed an accelerated pace of heating. Increases in greenhouse gases in our atmosphere, such as water vapor, carbon dioxide, and methane, are contributing to the heating. In the future, expect warmer climates and more precipitation in some areas. Also, we can expect higher sea levels as glaciers will melt and water will expand.
Oh boy, that's scary stuff. Well, I finally reached Mars. Let's get on with it.
Well, Al, what's it like? Are the rumors true? Is there life on Mars?
Well, Caroline, it's kinda cold and looks like a desert. Mars is truly evidence of what long-term climate change and atmospheric decay will look like. Its atmosphere is almost 100 times thinner than Earth's. Also, carbon dioxide forms nearly 90% of the atmosphere. Nitrogen, oxygen, and argon are also found in traces as well. Despite having such a thin atmosphere, Mars still sustains winds, clouds, and weather.
Wow, that's very different than the atmospheres of the planets we've already seen. You were saying earlier that Mars has experienced atmospheric decay. What does that mean?
Well, look closely. On the surface of Mars, there's evidence that liquid water was once present. There are clear indications of river plains and ocean boundaries on the surface.
Dear God, were there once aliens?
That's quite complicated. It's still debated among scientists, including myself. Currently, there is no substantial evidence that there was once life on Mars despite the existence of water.
What? Then what happened to the water?
The atmosphere has thinned as a result of Mars's weak gravitational pull and weak magnetic field. Activity from the sun virtually stripped Mars of its atmosphere, leading to a much colder planet. The average temperature is negative 80 degrees and can get much colder at the poles. It sometimes even snows, except it snows carbon dioxide rather than water.
Wait, Al, what's happening?
Dear God, it must be one of Mars's dust storms. Mars has some of the largest dust storms in the solar system. These are capable of blanketing the entire planet for months at a time. I gotta get out of here.
Now to the planet everyone's been waiting for, the largest planet in our solar system, the ultimate gas giant, Jupiter. Just to give you a scale of how big Jupiter actually is, it is about 2.5 times more massive than all of the other planets in our solar system combined, and its diameter is 11.2 times larger than Earth's. As its nickname, the gas giant, suggests, Jupiter's outer layers are mostly composed of molecular hydrogen and helium gas. As we move inwards, the molecular hydrogen becomes liquid, hydrogen then forms a metallic layer, a water layer becomes present, and finally a small rocky core. Al, I'll hand it off to you.
Thanks, Caroline. As we look at Jupiter's dynamic surface, we can see striking white and red bands going around the planet. The colder white bands are known as zones, while the darker red ones are known as belts.
Yup, it's thanks to Jupiter's winds that keep these zones relatively separate. Oh my God, look! It's the Great Red Spot! Don't fall in, Al!
Don't worry, Caroline. Located at the southern hemisphere of Jupiter is the Great Red Spot, which is actually just a large storm that makes the clouds around it swirl. If we observe the Great Red Spot for 6 days, we will be able to see its full cycle.
Wow, with winds reaching about 400 miles per hour? Don't lose your microphone, Al.
In the troposphere, temperatures ranging from negative 240 degrees Fahrenheit to negative 150 degrees Fahrenheit. But let's dive deeper into the atmosphere.
As we dive down closer to Jupiter's core, pressure and temperature increase. Another fun fact about Jupiter is that its magnetic field is about 20,000 times stronger than Earth's. It's so strong that it can sometimes produce stronger radio signals than the sun. Al, are you okay?
If you decide to visit Jupiter, make sure you bring gas masks.
Moving on to the next planet of the forecast is none other than Saturn. Al, report back. How is it there?
Ring ring, Caroline. It's me, Al. I'm on one of Saturn's rings.
Oh, Al, your jokes are almost as toxic as the clouds of ammonia ice on Saturn.
Ha ha. Let's get on with it. Saturn's atmosphere is composed primarily of hydrogen at about 93%, while the remaining is helium. Helium accounts for almost a quarter of the mass of Saturn, yet it only makes up 7% of the atmosphere. Methane, ammonia, oxygen, and nitrogen are also found in small traces.
Seems like a pretty complicated atmosphere. I see cloud layers quite similar to that of Jupiter, but not as distinct.
Correct indeed. The temperature gets warmer as we move from the exterior of the atmosphere to the interior. This affects the appearance and characteristics of the planet. The upper clouds are mainly ammonia ice, and the lower clouds are mainly water ice. The lower layers have higher temperatures and pressures.
Makes sense. That must be the Great White Spot. Those are large storms that typically occur once every Saturn year, or 3 decades in Earth time.
That's a dwarf star for you, Caroline. If you look towards the North Pole, there's a hexagonal-shaped storm big enough to fit 2 Earths. Rumor has it that winds are moving upwards of 220 miles per hour.
Wow, that's fast. Before we move on to Uranus, let me tell the viewers about Saturn's amazing rings.
Sounds good.
The width of the rings is almost 240,000 miles wide. Scientists believe ice-covered rocks or icy snowballs are the particles that make up the rings. Some are not visible, whereas others are the size of a bus. There are many gaps in between the rings as well. The different layers have distinctive features. Saturn is truly incredible.
You got that right, Caroline. That's your second dwarf star of the night. Now off to Uranus.
We're nearing the end of our forecast and are arriving at our penultimate planet, Uranus. The planet's composition remains much like the other gas planets from our forecast, with hydrogen and helium primarily composing the outer edges, then a layer of water, and a potentially rocky core. Al, give us that report.
Well, Caroline, Uranus has the coldest atmosphere in the solar system, with temperatures in the troposphere ranging from negative 243 degrees Fahrenheit to negative 370.
Oh no, I'll make sure to send you a hat or something.
Yeah, thanks, because you really care about your reporters. Anyway, as we move down the cloud layers in the troposphere, we will be able to see water clouds and ammonium hydrosulfide clouds. Ammonium clouds come next.
Wait, Al, I can see some stripes on the surface of Uranus, but they're moving vertically across the planet. What's going on?
Well, Caroline, Uranus is the only planet on our solar system that rotates on a completely tilted axis. Some astronomers believe that Uranus was knocked on its side during a collision. This makes the seasons here very extreme.
Wow, Uranus is cooler than I thought. If you're planning a vacation there, visitors are in luck as there are minimal storms because it's so cold. If you're lucky, you'll be able to see some auroras. But Al, why does Uranus appear blue? I thought Neptune was supposed to be the only blue planet.
Uranus's blue color comes from a thin layer of methane clouds on the top of the planet's atmosphere. Because methane absorbs red light, our eyes see the reflected blue light.
Well, now that we cleared that up, let's move on to the actual blue planet. It's none other than Neptune.
Time to blast off!
Wow, it's time for the grand finale, Neptune.
Brrr. It's so cold. I'm from Florida. We don't ever experience this kind of cold.
You should have gotten yourself a Canada Goose, Al.
Ha ha ha, moving on. As expected from the gas planets, the atmosphere of Neptune is also primarily made up of hydrogen and helium. Methane in the atmosphere also produces Neptune's blue color because methane absorbs red light. Amazingly, there's 100 times more methane near the equator in comparison to the poles.
That's right. The cold temperatures allows for the methane to condense into clouds in the outer atmosphere. The haze present on Neptune is also due to the presence of smog made of hydrocarbons.
Speaking of clouds, do you see these storms? Winds on Neptune can move as fast as 1,000 miles per hour. Speaking of winds, they're beginning to pick up speed. I'm getting a little worried.
Despite being the same temperature as Uranus, what is causing these storms?
Well, uniquely, Neptune has its own internal heat source, likely residual heat from formation. This is something that Uranus just doesn't have. That's why Neptune and Uranus have the same temperature despite Neptune being further away. The heat flow likely causes the extreme weather as well. Whoa, wait, what's going on? Ah!
Al? Al? Are you okay? Darn it, that's the 15th field reporter we've lost this light year. At least we have our interns.
Tell my dog I love it!
Well, that's all for today's solar system forecast on the Astro Network. Tune in later tonight for more weather updates. This is solar system reporter Caroline Lee signing off. I would sign off for Al too, but he's unfortunately lost in a black hole. See you tonight! Forecast, which is Venus. Oh wait, we're in a thin, rocky outer layer.
Thin, it's thick.
No, it's thin. I looked at my God. Sphere. It's a cozy. Okay, this is taking. Oh wait, the Mesosphere. Are the rumors true? Is there life on Earth? Then what happened to the water? I'm gonna sneeze. Sometimes produce almost 240 surface of Neptune. Oh, what did I say? Neptune. Vacation to Uranus. Hydrocarbons is causing these storms. That's all for today's
In the field. You're supposed to throw the spike ball. Planets in our solar system. Eccentric orbit and gas clouds create a short. It's almost as pole. And I looked at red and white spread. Let's dive down into
Okay, wait, what? It starts off blurry.
atmosphere to the interior.
Interior.
Damn it, I'm so close.